Don't agree with that.
All right. All right, clap your hands if you can hear my voice. Clap your hands 2 times if you can hear my voice. All right, thanks for sticking with me through the walkthrough. I hope it was helpful to most, if not all of you. You'll definitely have to do stuff like that again someday. Anyway, so I want to keep the rest of today's lecture pretty short. Probably wouldn't be able to make it that long anyway, which is like, we're going to start learning about Node. Right now we're starting season 3, and we've already done a lot of Node stuff a little bit. We maybe don't know that much about it yet, but we've been using it, right? We've been running files when we've been like Node homework.js, right? And then it's run it. So that is Node. So let's talk about like what is Node, diving deeper into programming languages a little bit, and installing. You've already installed Node, so that's set. Going off of the README mostly, just because it's not that much to really go into. Hopefully you guys read it on your own last night, so I can just kind of like zip through it. So it's talking about how does a computer work, right? And it talks about how every machine really only understands like these ones and zeros. That's totally binary. And so we created, in the 1950s, apparently, higher level programming languages. These languages are like C, Fortran, Pascal, and C++, or I guess I can show you what I'm looking at. And so what these things essentially do is they compile the code into binary. So that's why some of these languages are even harder to learn. If it seems like I've looked at them and I'm like, I don't know what that's saying. And that's because it's closer to speaking like a computer. JavaScript is not one of these, but it's still closer to the computer than, let's say, the language Ruby. Ruby reads like so much like English. I think it might get compiled a couple times even, because it's just abstracted a bit away. So these are like the high level languages, and then there's like assembly language, machine code, and interpreted languages. So where does JavaScript fall into it? It was developed in the 1990s. I think it was like in 10 days, right? Yeah, it's not a higher level thing, but it's a special type of program that does the following. It makes network requests to the internet to retrieve data and interpret and display the data it receives. And so JavaScript, HTML, and CSS are all interpreted by your browser. That's awesome. And it only works if your computer program, such as a browser, interprets it. So this was originally. And then came Google's JavaScript engine V8, which allows us to run it without a browser. It says, okay, now we don't need the browser for JavaScript. We can just run it in what's Node. This is this environment. And so we've done Node. And it's got some add-ons. So let's read this together. Standalone JavaScript on the browser. It's have a lot of capabilities we need to handle server-side programming. Node.js includes many of these. many new libraries and tools to allow us to do the following. So it allows us to input and output buffers, right? So this is like handle binary data, file system, manage files on your machine, HTTP networking. That's like sending things out for requests and to get information back. Streams and pipes. This is a really cool one. So like you can handle information coming in not at the same time. Like if you're trying to bring in a bunch of data, I guess their example is video streaming. It'll be like, oh, here's a portion, and you can like work with that portion while the other portion hasn't come yet, and then it like breaks it into chunks. So it's a lot faster, right? Because you don't have to wait for like all of it to come. So that's pretty tight. And access to the operation system, running Node. So we've already done this, right? You've installed Node in your computer. We did this on day 1. And then it just talks about how you can run files on your Node by making an app, like not an app, a file, like a JS file, and saying Node, and then the name of that file. Okay, that's the first part of today's lecture. I just wanted to kind of zip through that. Any questions that I might be able to answer? Yeah, JR.
So essentially, what it's saying is that you can actually make a computer program using the Node.js, just like we would use like Python or C++ to make programs.
Tell me what you mean by that.
So basically, you know, like how you can make like a standalone program on Windows, for example, using like C++ or using Python. So is that Node.js essentially like using JavaScript?
Yeah, we can use JavaScript for the whole thing, everything, front end, back end. So yeah, Node's really helpful for us to run our JavaScript in the back end, because it was like kind of, yeah, I guess it kind of talks about like it was just in the browser for a while. So that's all just front end stuff, and we were needing the browser to interpret this JavaScript. But JavaScript's kind of a good language to write in. It's kind of fun. I mean, if you get used to it, then you want to go to the back end. If you don't want to switch languages, it's kind of cool to be able to continue to write JavaScript. So that's what Node's doing.
That's what I wanted to ask you. Like, since now JavaScript with Node, you can do backend stuff. Is there limitations to what the language can do compared to other languages?
That's a good question. I don't know. I'm not that familiar with like all these other languages. I think that those higher level languages like C++, I think they're faster, because they're closer to the machine code, so they don't really have to be as interpreted.
Oh yeah.
Right? It's like talking to someone who speaks Spanish and you have a translator, but then if you want to speak someone in German and you have to speak to that translator who speaks to a different translator that goes from Spanish to German.
Yeah.
Something. Yeah. Okay, that's good. Next thing is we're going to talk a little bit about importing and exporting and like what node modules are. Because like we've used the word npm a bit, right? We've kind of like, we did like npm install, readline sync and stuff. So what is that? Well, that is, npm stands for Node Package Manager, and it takes in modules. What's a module? A module is a bunch of code somewhere. It's a bunch. I can read it. If you want. Yeah. So like a library has all this code that you have in your disposal, right? So Axios, there's a Axios module. So like after coming up, instead of adding that script tag, right, we'll just npm install Axios, and we'll get that Axios module. And some genius somewhere wrote all of this code that allows us to go right axios.get and get a bunch of stuff we get to sort through, right? So that's pretty cool. So there's a few different types of node modules. I can show these too. Oh, did I just delete it? Let me bring it back up though. Oh, is it here? Where is it? Yes. To show you the three different types here. Right, we've got our core modules. These are things that come packaged in Node. So if we remember when we first used readline for like that rock, paper, scissors game, we didn't have to install readline. Do you remember? Like none of us wrote npm install readline. We might have done readline sync, but we didn't have to do readline. So readline comes with Node. So does fs. That's like a file system reader. And then we also have local modules. These are modules that you define and create. So back to our tic-tac, when we were doing tic-tac-toe, maybe we separated our classes and we had like a board class and a human class and a game class. And then we wanted access to what was going on in our human player. We had to bring that module, which is like have access to that code. That's why we did that import. We exported it, we kind of remember. If not, it's all right, because that's what we're gonna go over. And then we imported it in the file that we wanted it. And so that was a module that we had created. We just weren't really thinking about it as module, we're just separating our files. But really, we're accessing all the code that we've exported from that file in a different file. Yeah, David.
What makes it a module that I'm using that word or module creating function?
It's code coming from not on the screen, essentially. If you're accessing code that's not on on the main screen where you're using it, I guess that's how I would consider it to be a module. Okay, and then there's the third-party modules. These are things that are created by other people, like readline sync, right? We didn't write that. It also didn't come with Node, but someone else wrote that and bundled it up and was like, wouldn't it be cool if JavaScript was synchronous? And it's like, okay. And it worked well for that situation. But that's the third-party modules. Okay? So there are a couple different concepts for importing and exporting modules. This does change when we start working a little bit with the browser eventually, and we move back into ES6 land. We actually just get to write the word like import, and we get to say what we want and export, like export default, whatever. But for now, which is I think the same way we had to do it for the tic-tac-toe game, is we have to use require and module.exports. Requires a keyword, and it looks like this, right? You declare a variable that you want to use, and you say like, all right, require, and you like if it was a math.module, we'd be requiring all of the things that are exported from this, and then this is an object, math.module, that we can access specific functions, which are keys, named functions, in this object. If that's a little confusing, that's okay. We're also going to like look at it.
All right, you said that's an object.
Yeah, this will be an object. This, when we require, it's giving us back. Oh yeah.
It's kind of like the idea of how APIs are. Like,
Yeah.
we're storing an object, so the node is kind of stores the code into an object to be used.
Yeah, exactly. It's kind of like that. It's getting back some of that data from that API request, right? We kept doing response.data to get that array because we wanted that array, but we always got back like this object and it had a bunch of keys attached to it, right? Data wasn't the only key. It's just the only one we seem to ever care about. Yeah.
So where it says ./math.module.js, that's just like another JS file somewhere else that we have access to because we.
This one would be for a local.
Okay.
Yeah. So like, all right, let's get into like some code here. I gotta make a form. So we'll say touch mod.js. Let's get into mod. What is it? Option. Okay. So I can say, like when we were doing read line, we were saying like const read line, and we were saying require. Oh my God. I'm sorry. This is so big.
Yeah.
Does it need to be this big for everybody in the back?
No.
Is that still nice? Really? Okay. right? So we could have done readline. This is, I think, how we did it, right? And then we have access to readline. Actually, I can't. Let's like console log. I don't think I can't use debugger in the terminal. Not with this current setup. And I'm gonna console log what readline is. And I'm gonna go node mod.js. And readline is this massive module. But we see it's an object. It's got some interface function, clear line. I think it probably has question somewhere, right? Wasn't one thing where we would go readline.question somewhere. Clear line. Right, it's got all of these things. I could install npm, I could readline sync, but it would look like something similar. It's like we get back to this object of code. And I'm gonna create another file because I think we're gonna end up going that way. So I'm gonna say touch math. Yes. Oh, didn't like it. Okay. And so we'll get there in just a second. Let's talk about exporting for a minute. So let's say I write a sum function. So I'm going to write that right here. I'm going to say in my math. I'm just going to do math, right? So I'm going to say like sum. Well, let's call it adder. We'll get away from the example a little bit. And it takes in num1, num2 function, and we're going to return num1 plus num2. Very exciting, right? So I go, okay, well, wouldn't it be fun to, I'm going to get rid of readline for now, be like, I want to use math. I want to use some math in this file, but I don't want to clutter up this file with a ton of math, right? Because who wants to do that, right? And so we can do this export. We can say module.exports, and so I can go back in my math. I can go module.exports, and this takes in, this is an object. It's just like all the other modules, right? We saw were objects. This is also an object, and I can do the key of adder pointing to adder. And this is what I did when I wrote your Unit 1 test for those like specs. I don't know if you noticed, but at the very bottom of your test, it said module.exports, and then it was exporting all the functions that I asked for. I also pre-wrote them because otherwise it would throw like a lot of errors because I was importing them somewhere else. Because all of those functions I imported on the Jasmine side when I wrote the spec, and so it had access to the function on another page.
I thought we just added the function name automatically created an object of that. No? At least that's why I didn't even think that code when we're communicating the pages.
That's because that class was an object.
Or else we would have to do it.
Right. This is how we're exporting a function. Yeah, Johnny.
The value is the function, and the key is whatever we can call it.
That's right. But it makes sense to call the key the same thing as the value, because we don't want to be confusing. You know what I mean? If I call it raccoon soup, like how when they import it, they'd have to say math.raccoon soup and know that it's an adding function. So like it's definitely good practice to like call it the same thing. Okay, so now let's require. So over in here, I'm going to say const math, and I'm going to require it. I'm going to use require the keyword, and this is the local path. So /, what math I could say I can. The JS at the end of this is optional. I can do .js or not, and it will look for the JS. Personally, I always write JS. I'm just like, I like to be totally explicit. So let's see. I can go console.log. I'm going to say math.adder, because remember, adder is a key on this object. And I'm going to pass in 5 plus 5. So if I save this and I run it by writing node mod.js, we're expecting to see the number 10. NaN. Why? Good point. Good catch. Right? Let's do a math right there. I got too excited. But it worked though, right? It didn't throw an error saying, hey, there's no function adder. Right? Because, all right, it gets 10 now. But like if I didn't have this, right? And I'm like, it would say, like, wait, what are you doing? You're not.
That you call it in a different way, like you call it as if it is a method, like a property, like we used to do array that product that.
Yeah.
Then you call it the same way, only because it's in an object, right?
Right.
Okay.
So only because it's an object. I'm keying into the object. I'm not actually calling a method. That's a really good point. Yeah, Johnny.
Base console is set up that goes to like math.key. It automatically goes to value. You're doing like
there is no method. When you key into an object, it gives you the value. Unless you're writing a setter.
How can you give it an argument if you're just keying it?
Because when you key into it, it returns a value. Right, if I have the object, let object equal Corey soup, and I go down here and I go object Corey, what's that give me? Right, it's soup. So, same with if I did Corey, what's that give me? Soup, boom, right? Bada bing! So, when I say math.adder, it just goes, boom, there's your function.
So it's kind of interpolation, you just add the parents next to it because it gives you a function, and then have the parent.
Oh yeah, because I don't want to save this for later. I could save this function as adder somewhere else. I think I can even do like let adder equal math. And then I can do here. Let's see if that freaks out or not.
Maybe you have to do adder.adder. Yeah.
Hang on. No, that's what I'm checking. No, it doesn't like that.
What is adder.adder? You're also not bringing it in.
Oh, I'm not bringing it in. Thank you. Let's see if it works. It might work as of object destructure. Oh, adder is not a function. But now it is. Okay, but we don't need to do that because we can access it directly by going math.adder. Okay. Any other questions on that so far? Yeah, Matteo.
Can you do two things? Number one, can you console log math.adder without calling it?
Sure. So I'm going to console log math and math.adder. And we get, this is a function called adder, and this is just the function.
The left side is an object.
This is the object, yeah. This is the math. And this is the mad adder.
Always a object.
I think so. Yeah, Johnny,
Like, would callbacks work?
tell me what you're trying to do.
Like, let's say we have sum and multiply in math.js. And then the values of math adder you want to put into multiplications. 1 to the 10.
Well, I could do math.multiply, and then as an argument of that, pass in whatever I get from math.adder.
Okay.
Definitely experiment. Okay. So this is one way. So if I had a couple things, I'm gonna just swipe this person's thing, and just put that here, right? If I want to add more things, I can do multiply, multiply. We're okay with this way of exporting and importing. Okay, so now I want to show you something kind of cool with ES6. So if the key and the value are the exact same name, you actually only need to write one thing. So I can write adder and multiply, like so. And when we go over here, let me just show you that it works. Let's prove it to ourselves. 5 and 6. We get 11. So that's kind of a cool, sexier way to set up an object. I highly recommend doing things like that for this type of thing. It will come in handy also when we get into Redux in season 5. Absolutely. This one?
And the syntax sugar is just the same as putting adder and semicolon adder.
Yep, this is just syntactic sugar. It automatically is saying that the key and the value are going to look the same. Yeah, but yeah.
Do you mind just console logging math?
Sure. It will look like two functions in an object. Kind of cool, right? We're like, yeah, whatever. How are we going to use it? They're like, we just pulled information from the sky and put it on a screen. I don't care about this. Well, that's okay. You'll care eventually about it. It's kind of cool. I mean, we're getting information from another file. Here's another way you can do it. I don't think I need to go into all the, like, I'll show you all the ways. I don't think I need to type them all unless you guys really want me to. But I do want to try to keep it short for the Uber people. But yeah, you could also do like where your key is the name of the function you want, and then this is just an anonymous function, right? Make sense? Yes, no? If not, let me know. Yeah, of course. So in our example 3, we're doing the same kind of thing here. We're just saying like the key is the word sum, and then instead of writing the function like up above somewhere, we've just written an anonymous function directly as the value. Yeah, John.
Show that working, the anonymous function.
Sure, I can make it one.
Wait, so what that was the point of, why didn't you just write it in the other file?
Well, it's still exporting. It's right here. So instead, I can just go yoink. Okay. I'm going to remove this one for now. And here we still will get 5 and 6. Oops, I should do that adder. Did I say adder or add? But we'll find out. Oh, I did, okay. All right, so that's just this working. All right, let's keep going through the other ways. So you could also just keep listening, right? So module.exports.sum equal to sum. Module.exports.multiply is equal to multiply. So you could just keep listing those, because this is just, if we know that exports here is a object, right? This is just setting a key as the object into the object and giving it the value of the function. Questions on that?
Sorry, can you
Yeah.
repeat that?
Yeah,
That part, by storing it.
this part, right? So we can add keys into objects by doing dot something and then assigning it a value. That's a setter.
Oh, it's stored.
Yeah, so that's all that's doing. It's just storing this key into exports with this value. And last but not least, we could write module.exports.sum.multiply before each one.
So like method.
So instead of having this, I could do module.exports set the key dot multiply, oops, and have this point, right? Is that what that was? No, it is equal, of course. Okay, right, and I'm assigning it the value of this anonymous function. I should get rid of that n, because that's not doing us any good. Save it, let's go over here, do multiply. Should get 5 times 6 is 30, right? 30, great. Cool. Just different ways of exporting. And that's it. That's the whole lecture. I got it done before Uber. So your assignments set up a little differently at the moment because they haven't been put into like an assignment folder. So anyway, there's a link in your Canvas though, which is like module exercises and create a module. Your assignment, or it's not quotes, it's an assignment. Your assignment is just make your own folder and then push that to your own GitHub repository. You don't have to fork it. Okay, you don't have to fork, just push it to your own. Make your own repository, push it into there, and then submit the URL to that repository. For this one, we might be able to change it back. Some of the units are set up slightly different. Any other questions? No? All right, awesome. Let me know if you have questions. Okay. Thank you. Standing ovation, amazing.